My goal in building this project was to create a machine that embodied the classic look and feel of the machine presented in Turing's 1937 paper on computable numbers. At the heart of the machine is the read-write head. It has the ability to write, read, and erase from the tape. Writing on the tape is done with a standard fine-point dry erase marker. The marker is moved in the y-axis with a servo. The transport of the tape provides the x-axis motion. The marker is lowered and lifted from the tape with an additional servo. Erasure of the tape is accomplished with a felt-covered cylinder. A small gearhead DC motor rotates the cylinder through a toothed belt and pulley system. The erase head is lowered and raised by a small pin in the base of the read-write head. This pin rides on a cam attached to a servo. To read the characters on the tape, a TSL 1401 line scan camera is used. This camera captures a single row of 128 grayscale pixels. By transporting the tape between scans, a complete character can be recognized. A bank of LEDs provides even illumination for the camera. This camera provides the only source of information the Turing program has for what is on the tape. The tape for the Turing machine is a 1,000-foot roll of white 35mm film leader. Motorized roll stands at either side of the read-write head automatically handle the tape. Transport of the tape is done with the cog at both ends of the read-write head. These cogs are moved with a stepper motor driving a toothed belt system. One revolution of this motor is equal to one cell of the tape. Just in front of the read-write head is the control console. This console contains a custom display board. Mounted to the back of the display board is a second PC board containing a parallax propeller chip. The propeller chip provides all the control for the machine. Adjacent to the propeller board is a third PC board that provides power and control to the servos and motors. The control panel of the machine gives you access to all of its functions. Through the use of a 5-position switch, you can load programs, define defaults, move and erase the tape, or run in single step through programs. Programs are written and saved to SD cards as simple text files from any computer. Once the card has been inserted into the machine, you can browse its directory and select the program you want to run. Often programs need to operate on a tape that already contains data. Default tapes can be saved as part of a program file. They can also be created and edited from the user console. Once a program has been loaded, it is started from the console. In this example, the machine is running a simple binary counting program. First, the default starting data is written to the tape. After the default tape is written, the tape is returned to the first tape position, and control is turned over to the Turing transition rules that were loaded from the SD card. While the program is running, 3 LED displays provide feedback. This includes the current machine state, the tape position, and a running count of the operations completed so far. Additionally, the 4-line LCD display shows the transition rules that apply to the current machine state. Each loop of the Turing program reads the current cell from the tape and uses the transition rules to determine if that cell of the tape needs changed. If it does, the cell is erased and written with the new character. It then changes the state of the machine if needed, and the loop starts again. In this simple binary counting program, the binary number is incremented each time the tape makes a full transition from the least significant bit to the most significant bit and back again. In this example, the machine is counting from 11 to 16. Because it takes 50 operations to do this, I have sped up the video to save time. When the machine reaches a halt state as defined in the transition tables, the Turing program exits from its loop and control is returned to the console. Thank you for watching this video. I hope you have enjoyed it.